So the following presentation is designed to enable our resellers and users to demonstrate Edgecam in a very broad-minded way. That's to say that we're going to be looking at a very broad range of Edgecam's products. We're going to begin at 2.5D milling and work our way right up to 5-axis. So the presentation material is obviously available for download. The material itself has been thoroughly road tested as it has been used at the Machine Tool exhibition in the UK this year, so it has been thoroughly tested. So I'll begin with an official introduction and then go through the demonstration with some suggested wording. The following presentation provides a comprehensive overview of the power and the versatility of Edgecam. It will include design modelling and demonstrates many of the strengths and features of Edgecam Solid Machinist. Moreover, you'll witness the power of Edgecam's customization tools, including both command macros and the strategy manager. At the conclusion of the demo, you'll have gained an insight to the breadth of Edgecam's product range and also how CAM programming can be automated, thus decreasing programming time and increasing customer profits. So our demonstration here begins with a standard 2.5D mill component produced inside Edgecam's part modeler product. And the part modeler is a 3D modeling tool specifically designed for quick and simple construction and a modification of solid model files. It's cost effective and it's easy to use, ideal for the production engineer. And it comes with a very complete and versatile associative drafting capability to create a paper drawing from the model. It's the perfect complement to Edgecam Solid Machinist and provides advanced modelling tools to create parts or work holding systems such as chucks and fixtures and indeed machine tools themselves. And later in the demonstration you'll see how Edgecam interacts not just with Part Modeler but obviously with any CAD model file in the industry. So here we see Edgecam Part Modeler. We point out obviously some of the features. We have our document control panel, which is obviously used to allow the user to see and understand what procedures have been modeled beforehand. As we click on each of these features, you'll see how they easily highlight. If we wanted to say add on an extra feature, what we'd simply do is just go along to, in this case, let's have a fillet feature. Let's place a size in here, and in Edgecam we just simply request, well, what do you want to feature? And I'll pick all that edge and then just do an apply and OK. Obviously this could be a variable fillet, in this case a standard fillet. And then what we're obviously seeing here is the fact that we have that fillet perfectly formed. If we don't want the fillet, we can just either suppress it, so we're not actually going to delete it. It means suppressing, very useful for machinist people who actually want the feature on the model but don't want it to be machined. We can take them away by suppressing, or indeed we can just delete the feature. But the strength of Edgecam Part Modeler is how powerful it is for such little money and how easy it is to use. If we look at these counterbore holes, how were they formed? Well, if I just do an edit on that particular procedure, here we see a very easy intuitive dialog box, and every time we click into a field we can see which particular parameter we're affecting, and it comes obviously with a little bit of online help there as well to help a user know and understand exactly which section of the software they're affecting. So that's Edgecam Part Modeler. Now if we take that model through into Edgecam, what Edgecam's going to do is it doesn't affect the integrity of the design. It's always maintained because the solid model is imported without translation. Edgecam Solid Machinist uses automatic feature recognition to interrogate the solid model and quickly identify machinable features. And of course the breadth of model files can be imported into Edgecam, including Solid Edge, SolidWorks, Inventor, Pro-E, even NX files. So in this instance the part has already been fixtured and the features have been created. And as Edgecam is one of the best looking CAM packages in the marketplace, observe how easy it is for us to display the machinable setup, even turn off the machine tool, rendering the stock and rendering the features that I keep alluding to. So here are the features on the bottom of my screen. As I click we can just go and understand a little bit more closely exactly what feature is being affected and where. So it's very important for the user. So how long would it take to actually machine a part like this? 10, 15, 20 minutes. Well, with Edgecam Strategy Manager, that's taken down to seconds. What we simply do is just select this icon here and look at the left hand side. The features and the machining is already taking place. So we're going to get 31 rationalized CAM instructions within a matter of seconds. And it's obviously important for the user to have faith in this particular procedure. So this is why we always use the Edgecam machine simulator. So it's not just a case of wanting a pretty machine tool to aid a demonstration. It's practical. We want the user to have peace of mind that when he presses the go button on his machine tool, that he's going to see no collisions and they're going to get exactly what they see on the screen. This is obviously extremely important because we want zero scrap, zero downtime and maximize profitability. So using solid models yet again, a machine tool is built up and assembled inside Edgecam, or indeed it can be modeled in any other CAM package, or rather CAD package, then brought through into Edgecam's Code Wizard in this case, where the full machine tool kinematics can be created. And as we can see on the screen here, we've got a perfect CNC tape. Now, how many times have you had to reprogram a part due to a last-minute design change? The loss of time and revenue can be quite significant if a CNC program has to be altered due to the designer changing his mind. Now, this is not the case in Edgecam Solid Machinist. Design changes are seamless and zero downtime is a factor. So this zero downtime is extremely important. Obviously, the faster we can alter, the quicker we're back up in production again. So this is where we're going to see Edgecam's associativity. If I go back to Edgecam Part Modeler, which is obviously where that model came from, and we begin to make some changes. So in this particular case, I'm going to change the shape of that particular pocket. I'm going to put some fillets on there. So here we can physically see some significant design changes. I'll go ahead now and save that particular part. If I come back to Edgecam, look at the message on the screen. And this would work across a network as well. If a designer had changed the file over in a building 2 miles away, because the network is sensitive to the file captured inside Edgecam, it's going to return this similar message. So if I just accept that particular message, what Edgecam's going to do now is it's going to regenerate all them tool paths. You see that clearly on the screen. And again, for that peace of mind, let's go back through to the simulator and let's make sure that what we saw inside Edgecam is true inside the machine tool simulator as well. So again, I'm going to press the go button, going to speed things up a little bit, and we're going to have 100% confidence to push the machine tool start button, knowing that we're not going to get any collisions. That what we see here inside Edgecam is what we're going to get out on the machine tool itself. So there's those 2 new pocket shapes now being perfectly produced. So not only do we have interaction with solid parts, but of course the final stage of any machine tool process is to actually produce the CNC tape. In this case, we're demonstrating it on a Haas machine tool, and the Haas machine tool uses a FANUC output, and there we go, we have our code. So the whole process took maybe under 1 minute, even with a design change. There's our CAM. But another challenge that programmers face is the need to change the machine tool. So in this particular case, we've just invested time and money in creating a FANUC style program. Now we've been told that this particular machine is out of service. Maybe it's had a crash, or there's a bottleneck in production, so we need to swap over the machine tool. So as a consequence of this, we have to reroute the part to a Cincinnati machine tool with a Heidenhain controller. So without Edgecam, this can be a very, very costly, timely experience. But as you'll see here, it takes a quick flick of the mouse to alter the machine tool and the part program. So what I'm simply going to do is swap over our machine tool. At the moment the machine tool is a Fanuc Haas, so I'm going to swap that to a Cincinnati Heidenhain. Just going to remount my datums again, because of course you might want to relocate that onto a different machine tool table. And I'm just going to run through that process again. Indeed, Edgecam's done that for me. We can see now we've got a new machine tool present, and obviously we need to just double check that everything that we're saying is perfectly true by proving it through the machine tool simulator. And again, if we just press the start button, we can see that all that has altered and everything again is 100% secure. And of course, how about the program? We needed a Heidenhain program in this particular case, so I'm just going to generate the code. And here we have a brand new program, which is the Heidenhain program. Beforehand, we did have a Fanuc program. So we have Fanuc on our left-hand side and Heidenhain on our right-hand side. And that changeover took a matter of seconds, really, thus demonstrating the versatility and the speed of using Edgecam and solid parts. So far, we've seen milling. But Edgecam doesn't just do milling, we're going to do some turning. And the same principle and the same processes are used throughout this one environment. One environment approach also allows the user to quickly and easily learn Edgecam, build up their learning curve, allowing them to advance through to the more complex parts and challenges that more advanced machining tends to produce for us. So we've got this kind of one hit kind of environment. So I open up a turn part. So how long would it take to actually machine this particular part? Well, in Edgecam, the whole process again, using Strategy Manager, using features, is seconds. If I create my features on here, so here we have turn features, asking Edgecam to produce turn features. Indeed, if in a mill turn environment, we might need some mill features on there. Then, as always, we're going to put some raw material, and that material can also be another solid model. And then we're going to go through into manufacturing, and again, it's very important to use machine tool graphics, especially in this particular part, because you're going to have turning tools, boring bars hanging out of the turret. You want to make sure that the boring bars or turning tools that aren't being used don't collide with the headstock. Again, if we stop and look at Edgecam's graphical interface, just turn off some of these features. Now we can see the features. We have a face feature, and again I'm talking about the base of our screen where we see the features being stacked up, and each of the features will allude to a feature here inside Edgecam. So what we're at liberty to do now is ask Edgecam to arrange those features in a machinable order. Now we can actually ask Edgecam to do that automatically through our preferences menu. In this case, we want to see that in a more manual format. So here we have a front face feature. Yes, I would do that as my first command. Then we have the turn feature. We have a bore feature, the counter bore. The back bore is the through bore, which in this case probably doesn't need doing, and a through hole, a drilled hole. So the back bore, I'm going to ask Edgecam to delete that. There's no need for that. But the front bore, which is the counter bore, needs to be machined lastly. So just using drag and drop technique, we're going to slide those around. And so now Edgecam understands we're going to do the face, we're going to do all the turning, we're going to drill the hole, and then obviously bore it. So now I'm going to declare this is my manufacturing order. So we'll see 1, 2, 3, 4, 5, the sequence for this particular procedure. Then I want to say assign my strategies. So we'll now see the names of the strategies being applied. And if you just turn back on some of our machine display, we'll ask Edgecam to apply the strategies, actually use them strategies. And so now on the screen on that left-hand panel you can see CAM instructions being created within a matter of seconds. And as always, let's use the machine simulator to guarantee that we've got good code, not only good code, but no collisions. And you can see in this particular part that we don't want the overhanging boring bar to strike the chuck. We just Just rotate a little bit and speed things up a little bit. So we've got turning and we've got finish turn. So strategy manager, not just for milling and for pockets and for profiles, but strategy manager is also for turning, as we can see here. And the strengths of Edgecam simulator, you just do a three-quarter turn here and peer inside the bore. The user's got 100% confidence to press the go button now on the CNC machine tool, knowing that there's going to be 0 collisions. But the thing for me, is that repeatable? Can that be done a second, a third, or the fourth time? Are there any smoke and mirrors here? Well, if I open up, we had extractor roll. Let's open up a family or a family of parts to extractor roll. So in this particular case, might not be too obvious. I'm just going to point them out. What we've got here is a different angle and a larger diameter. And also this overall length has been altered as well. We want to execute the same method on this particular part. So rather than have to go through the humdrum method again of manually creating stock and features and then going on into manufacturing, all we'll simply do is feature find it as before. Let's place our stock on there as before. We've passed through into manufacturing, we've gripped the part. Here's the features. We're going to inspect them features. So from experience, we probably know that we don't need the front board, and I'm just going to do some unrendering. So I don't want that back boring to be used, so I'm going to do a delete as we did before. I'm going to use the front board, but that goes lastly. So now my manufacturing order can be declared. I can assign my strategies and then just apply the strategies. So a different part, a similar part, the same strategies, and obviously a perfect solution to customers with frequently machined parts, or what we might want to term a family of parts. So let's step it up a gear. So far we've looked at 2.5D milling and 2-axis turning, but what about the more complex machine tools with multi-axis? These tend to create bigger challenges to programs. Now again, you'll find that Edgecam takes this comfortably in its stride. So if we change the part at the moment, we're going to see full machine tool graphics are going to be crucial to a machine tool like this. This machine tool on average could cost 250,000, 500,000 machine pounds to buy a machine tool like this. So it's obviously clearly very, very expensive, and we don't want to cause any crashes on this particular machine tool. The discipline of the machine tool is also that we've got sub-spindle. So we want to do C, Y-axis, B-axis machining on this part, but also transfer across to the sub-spindle. So again, imagine how long it would take to program a part such as this. But with Edgecam, this process, thanks to Strategy Manager, is made extremely simple. Again, as I use the same principle, I'm going to assign my strategies and then start applying the strategies. And on that left-hand panel, if you just observe, CAM instructions are now being produced. And what you'll see here is not straightforward, easy CAM instructions. We're looking at synchronization commands, we're looking at dual turret commands, we're looking at sub-spindle operations to the main to the main spindle and to the sub-spindle, as well as facing, turning, boring, drilling, tapping operations. So we've got Strategy Manager has come a long way. We've gone from 2.5D milling, 2-axis turning, all the way through to full sub-spindle mill turn environment. Again, giving the user the flexibility and the versatility to machine and have the confidence to produce a program of this magnitude within a number of seconds, and to make it repeatable as well. Here we see our C-axis milling, and then we get an index back to C0, and now we begin the operations for doing milling. And all the time we're looking for collision, and the user's looking for peace of mind and confidence that this is going to work first time out on this machine tool. If we crash a machine tool like this, we're talking very expensive downtime. If we scrap material, raw material costs, as we know at the moment, are escalating every day almost, so we want to make sure that material is saved every single time, saving this time, money savings, efficiency savings, zero scrap, zero prove-out time. All these things lead to increased profitability. Here we see sub-spindle crossing over, and again that's important. We don't want to crash the sub-spindle into a waiting turret. Now we begin machining on that sub-spindle. So we see just straightforward turning down the face, and now we begin to see finished turning, and now B-axis and C-axis begin to work. Okay, so again, Strategy Manager has made all this possible, making the whole process automated. So what is Strategy Manager? Let's have a look at Strategy Manager now. This is typical strategy. There's no confusing code to be learned here. What Edgecam Strategy Manager is doing is it encompasses the best from the principles and rules and knowledge of feature-based machining and utilizes these to produce a fast and reliable, highly automated solution, as we've seen. Strategy Manager offers a true knowledge-based machining because it's extended the feature-based approach of Edgecam solid machiners, combines this with the knowledge and the experience of the skilled engineers and shop floor operators, so it effectively drives the CAM process, and as a result, as we've seen in this demonstration, machining methods are kept constant and consistent, and the best practices are also utilized. So there's no C++ program to learn here. It's just a nice, simple, easy to use diagram, and if we just use simple decision nodes. So if I say I want to create a decision, what is that decision? So I'm going to say, well, I'm going to add a constraint. What is the constraint? Well, we're going to say that coming to the bottom left hand side, if the diameter is greater than 20 millimeter, what do we do? Well, we might want to say in this particular case, I want to center drill it. I've just dragged and dropped the process. Then I want to drill it. So if it's smaller or greater than 20 millimeters, yes, this is true, give this a tick. And if it's greater than 20 millimeters, give it a cross. So this is our if then go to statement, and then at the conclusion of it, create an end node. So we terminate our logical flow, or we might want to go somewhere else. So just by redirecting strategies, this is our flow diagram. So I'm sure you agree it's an extremely simple process for a user to understand. So let's look at something a little bit more comprehensive now. We've looked at automation, but can Edgecam do manual programming? Well, of course it can. That's how automation has its foundation stone. Here we see again a very, very complex environment, mill-turn environment. In this particular case, it's a Gildermeister GMX machine tool, which is a Siemens control. And we can see obviously some very, very comprehensive machining going on here, but the thing that I'd like to draw your attention to is how difficult is it to create this CAM machining. Well, thanks to Edgecam's intuitive dialog boxes and operational control, it takes seconds, because this is the actual command that the user would have had to master, and it's not too difficult to master. As we move through this dialog box, just like inside Edgecam Part Modeler, the user is left in no doubt at all as to what part of the toolpath he or she is affecting. So again, thanks to Edgecam's intuitive programming tools, the task of machining something that ordinarily would have been very, very difficult for the user to produce is made extremely simple. And again, I'll just zip this across into the simulator, where again we see solid models playing a role, because of course solid models are used to build up the machine tool kinematics. We see some lower turret turning, upper turret on B-axis now. This is why we need these sort of tools. We don't want to crash the end of that tool onto that chuck, so this is why we need that machine tool simulation so much. Now we see a bar pull, now we see turning with balance turning. Very, very common question is to be able to clear material as fast as possible. So obviously we get 50% increase or 200% increase due to the fact that we can balance turn, and Edgecam handles this very, very simply and very, very quickly. So again, this is another example of a user being able to confidently produce a CNC tape, safe in the knowledge that they're not going to be witnessing any collisions, any crashes out on that machine tool, and that means profitability. We're not having to stop and use a lot of expensive production time proving out a CNC tape on the shop floor. It's being done here inside Edgecam. If we see a collision, it's better to see a collision here inside Edgecam than it is out on a machine tool where it's going to cost a lot of time and money. Better to break pixels on this screen rather than smashing up thousands of pounds worth of material or indeed machine tool fixturing on the shop floor. So we've gone on a very, very comprehensive journey, and the last area that I'd like to talk about is 4- and 5-axis simultaneous machining. So this particular product is designed to meet the demanding machining requirements of a lot of industries such as aerospace and automotive, medical, oil and gas come to mind. And Edgecam seamlessly integrates 4- and 5-axis simultaneous machining within its milling and its mill turn environment, and it allows a range of multi-axis cutting strategies to be applied, such as the 4-axis command that we've seen before. But just before we do, I'd like to talk about the actual machine tool configuration that we see here. Edgecam at the moment boasts a very comprehensive range of different types of machine tools. We've seen head-head machine tool configuration, we've seen table-table configuration, and now we're mixing the two together, table and head configuration. As we can see here, we've got a rotary table along with an indexable head, and also we have sub-configurations which include mutated head configurations and mutated table configurations. But how is this programmed? Again, using that easy to understand graphical interface. This is the roughing cycle. Again, as we step through, we see exactly what Edgecam would intend to produce depending on which field of that dialog box is being used. Further down, we see the 5-axis command, swarf command here. Again, how is that set up? Same as before. No difficult dialog box to have to negotiate. Simple dialogues explaining to the user the step-by-step procedure for programming that part. And again, we see swarf machining taking place here. Sidewall axial relief feed swarf machining, or 5-axis profiling, if you will. And again, we'll just conclude because obviously machine tool simulation is extremely important, again, to make sure that all the machine tool members, indexing, 5-axis, drilling, profiling, roughing, all these need to be simulated, all need to be gouge checked, all need to be collision free before we can confidently move forward and produce a CNC tape. So we'll finish the presentation now. I hope you found it of interest, and I hope you find that the material that's now readily available for download useful. Tool stores should obviously be set up inside Edgecam, and also your strategies will be available as well as the solid models that we used in this particular presentation. Thank you for your attention.